Okay, so one more example to do with this finding area between curves. I want you to once again pause the video for a second and try to graph these two graphs. Notice I say graphs instead of saying functions. Okay, we've got x equals y squared and y equals x minus 2. Okay, so if you have these graphed, this is what they should look like. And I said graphs, not functions, because this first one is not a function. That's your sideways parabola. That's not a function. So it's actually the two lines, or the two functions, y equals the square root of x, that's one function, and y equals negative square roots of x. So both of those combine to make x equals y squared, but x equals y squared is not a function. And then the line y equals x minus 2, that is a function, okay? So if I want to find the area that is bound by those two relations, I hope you're starting to see this, but that would be this piece right here, okay? Obviously, we've talked about area, and this one you have to use calculus for, just like we did in the last example. We couldn't have found that using area formulas, okay? So we're going to use calculus for this. So one thing you need to be thinking about when you're starting this problem is now we have the tools. Are we going to do this in terms of x, or are we going to do this in terms of y? So if you're thinking about x, it looks like that area goes from, from 0 to 4. Okay, but as you move from left to right, think about top curve minus bottom curve. Are we going to have to split this up or not? Okay, so as I move left to right, top curve is this y equals the square root of x minus negative square root of x. So it's square root of x minus negative square root of x. But then the moment I get to, I can't exactly tell exactly what that would be, but it switches and it's the square root of x minus the line, okay? So we would have to do two different integrals if we did it in terms of x, because the bottom curve actually changes for this example. It's always the square root of x on top, but on the bottom, it goes from being, let me highlight this, it goes from being negative square root of x, and then at about 1, it changes to being this line. So the bottom curve changes from that red to the green. Okay, so it's a little different than last time. Okay, now let's think about this in terms of y, which I know isn't as comfortable to do. We're not as used to this whole idea. But if I turn this and look at it here, notice, okay, looking at what's on top, as I move from left to right, it is always that line. Okay, it doesn't switch. It's always this line on top. And then if we do it in terms of y, it's always y squared on bottom, okay? So if we do this in terms of y, we don't have to split it up. And I know that this is definitely something that's going to be harder to think about. I definitely am going to anticipate questions from you on this, but if we go again from this left to right, thinking about it right minus left in terms of y, we don't have to split it up. Okay, so if we're going to do this in terms of y, we need everything in terms of y. We need our boundaries in terms of y. So if I'm thinking about y values here to start making my limits of integration with, the bottom y value, so the bottom y value, it's right here, but I can't exactly tell what that is. And I'm glad, because this didn't happen in the last example. So when you don't know exactly what the value is, where they intersect, you have some options. So on your calculator, you can calculate intersections. Okay, that's one of those options. When you hit second, calculate, intersect, you can find where they intersect. You can also find where two things intersect by setting their equations equal to each other. So if we're doing this in terms of y, I should go ahead and get this in terms of y, meaning I would add 2. So y plus 2, that means x is equal to y plus 2. So if I want to know the y value where this function and this function intersect, I set y plus 2 equal to y squared. That'll tell me the y value or y values where they intersect. And it looks like it's going to be values because this is a quadratic. So I'm going to move these two pieces over to the other side. So 0 equals y squared minus y minus 2. And we can factor that with guessing and checking. I think it would be y minus 2 times y, it would be plus 1. So by our good old ZPP, y equals 2, which makes sense. We can see that one clearly. And, you know, the tick marks didn't go by 1, but that is y equals -1. So that's probably what I would have guessed for that y value right there, but you have to be exact. So you might have to do that. You might have to actually set them equal to each other and go through and solve. Or you, like I said, you can calculate their intersection on your calculator. So we are going from the y value -1 to the y value 2. And when we're doing it in terms of y, remember that's right curve, which is the curve y plus 2, minus the left curve. Now, the thing about doing this in terms of y is the fact that the left curve, we don't have, it's in terms of y, it's just y squared. In terms of x, it's two different functions. Okay, so that's another reason we're doing this in terms of y. So it is y squared in terms of y. In terms of x, it is plus or minus the square root of x. Okay, so then this would be antiderivative. That'd be y squared over 2 plus 2y minus y cubed over 3 from -1 to 2. So again, this does just end up being a lot of computation because now you go in, you plug 2 into each of these pieces, then you subtract, plugging in -1. So you need to have parentheses in around that. Okay, so you have some homework to start working on, and I anticipate making some videos for those problems. So the homework for this that you need to be working on over the next few days is the textbook scan that I gave you the last time I saw you, which was Friday. This is what you need to be working on over the weekend. This would be your weekend homework. So over the weekend, start working on this. It is not easy. So if you run into problems, that's anticipated. We'll probably spend Monday and Tuesday getting questions answered. All of 1 through 21. You need to practice all of these. Okay. Some you're going to do in terms of X. Some you're going to do in terms of Y. Email me questions that you have.